Good morning, dear students. Welcome back to physics class. Today, I would like to discuss on two parts from this chapter. They are A. Pascal's law for transmission of fluid pressure and its applications, and B. is related numerical. In today's class, first discussing part is Pascal's law for transmission of fluid pressure. Let us do one activity to see what happens when the pressure on a fluid contained in a vessel is changed. For this, we have to consider a horizontal cylinder with a piston and three vertical tubes at different points as shown in given figure. Height of the liquid column in the vertical tubes shows the pressure of the fluid in the horizontal cylinder. It is necessarily the same in all. If you push the piston, the fluid level rises in all the tubes, again reaching the same level in each one of them. This indicates when the pressure on the cylinder increases, it distributes uniformly throughout the fluid. Circular vessel as shown in given figure. It consists of 4 openings, and along these 4 openings 4 pistons are attached. When the piston A is moved downwards, the pressure is exerted on the liquid in the downward direction. By doing so, you can see that all other 3 pistons move with equal distance outwards. Why did it happen? This is due to equal amount of pressure is exerted along all the directions. That is, the pressure exerted get transmitted equally along all the directions. As a result, they will move with equal distances outwards. Pascal's law for transmission of fluid pressure states that the pressure exerted anywhere in a confined, incompressible fluid is transmitted undiminished and equally in all directions throughout the fluid. The above law means that if we consider a fluid which is restricted within a specific region in space, and if its volume does not change with pressure, then the amount of pressure exerted will be same as the amount of pressure transmitted. Let us examine what are the applications of Pascal's law for transmission of fluid pressure. The devices which work under the principle of Pascal's law for transmission of fluid are hydraulic machines. Examples: hydraulic lift and hydraulic brakes. In these devices, fluids are used for transmitting pressure applied. Let you see what is hydraulic lift and how does it work. Hydraulic lift is a lift which makes use of a fluid. It is used in automobile service stations to lift vehicles. What is its working principle? It works on the basis of Pascal's laws for transmission of fluid pressure. Inside a hydraulic lift, there are 2 platforms. One has a smaller area and other one has a larger area. It is a tube-like structure which is filled with uniform liquid. There are 2 pistons, P1 and P2, which are attached at both ends of the horizontal tube. Let A1 and A2 be the cross-sectional area of the piston P1 and the piston P2 respectively. Here, the cross-sectional area of the second piston A2 is greater than the cross-sectional area of the first piston A1. If we apply the force F1 on the piston P1, the same pressure gets transmitted in accordance with Pascal's law for transmission of fluid pressure. It will be transmitted in all the directions and the same pressure gets exerted on other end. As a result, the piston P2 moves upward. That is, the pressure P is equal to F1 by A1 is transmitted throughout the liquid to the larger cylinder attached with a larger piston of area of cross section A2, which results in an upward force of pressure into its area of cross section. That is, in mathematical form, the force exerted on the larger piston of the area of cross section A2, which is F2, is equal to PA2. Since P is equal to F1 by A1, then F2 is equal to F1 by A1 into A2, where P is the pressure due to the force F1 on the area A1. So, F2 is equal to A2 by A1 into F1. This shows that the applied force has increased by the factor A2 by A1. So, its mechanical advantage is A2 by A1. Because of this Pascal's laws, the input gets magnified. That is, the force exerted on the larger piston, which is the output, is A2 by A1 times more the input force, which is F1. Advantage of using hydraulic lift is that by applying small force on the small area, it is able to generate a larger force or multiplied force. This slide shows that a car is raised through certain height by a larger force, which is F2. It is 10 times more the original force or the input force F1. That is, F2 is equal to 10 into F1. As area of cross section of the second piston A2 is 10 times more the area of cross section of the first piston A1. Then, in this device, the input force applied on the smaller piston in downward direction gets multiplied 10 times more to exert the upward force on the car. So, its mechanical advantage A2 by A1 is equal to 10. Then, see the numerical section. First question is, in a car lift, compressed air exerts a force F1 on a small piston having a radius of 5 cm. This pressure is transmitted to a second piston of radius 15 cm. If the mass of the car to be lifted is 1350 kg, calculate F1. What is the pressure necessary to accomplish this task? Given G is equal to 9.8 meter per second square. The solution is, given that radius of the small piston R1 is equal to 5 cm, converting into meter, it is equal to 5 into 10 the power of minus 2 meter. Radius of the second piston R2 is equal to 15 cm is equal to 15 into 10 the power of minus 2 meter, and mass of the car M is equal to 1350 kg. Then What are the area of cross-section of the first piston and second piston? They are A1 is equal to pi R1 square is equal to pi into 5 into 10 the power of minus 2 all square, and A2 is equal to pi R2 square is equal to pi into 15 into 10 the power of minus 2 all square. Then what is the weight of the car? It is equal to its mass into acceleration due to gravity. Let it be F2. F2 is equal to mg is equal to 1350 kg into 9.8 meter per second square. Transmitted undiminished throughout the fluid, the pressure P is equal to F1 by A1 is equal to F2 by A2. So, F1 is equal to A1 by A2 into F2. By substituting the values of A1, A2 and F2, we get it is equal to 1470 Newton. It is approximately equal to 1.5 into 10 the power of 3 Newton. To find air pressure that will produce this force, we have P is equal to F1 by A1. By substituting the values of F1 and A1, we get the air pressure P is equal to 1.9 into 10 the power of 5 pascals. Second question is, two syringes of different cross sections without needles filled with water are connected with a tightly fitted rubber tube filled with water. Diameters of the smaller piston and larger piston are 1.0 cm and 3.0 cm respectively. A. Find the force exerted on the larger piston when a force of 10 Newton is applied to the smaller piston, and B. If the smaller piston is pushed in through 6 cm, how much does the larger piston move out? What is its solution? Diameter of the smaller piston D1 is equal to 1.0 cm. Then its radius R1 is equal to 1 by 2 of diameter is equal to 1 by 2 cm. It is equal to 1 by 2 into 10 the power of minus 2 meter. Diameter of the larger piston D2 is equal to 3 cm. Its radius R2 is equal to 3 by 2 cm is equal to 3 by 2 into 10 the power of minus 2 meter. And force applied to the smaller piston F1 is equal to 10 Newton. Then we have to calculate the area of cross sections of these two pistons. The area of cross sections are A1 is equal to pi R1 square. It is equal to pi into 1 by 2 into 10 the power of minus 2 all square meter square, and A2 is equal to pi R2 square is equal to pi into 3 by 2 into 10 the power of minus 2 whole square meter square. As pressure is transmitted undiminished throughout the fluid, we have pressure P is equal to F1 by A1 is equal to F2 by A2. First we have to find force exerted on the larger piston F2. We have F1 by A1 is equal to F2 by A2. Then F2 is equal to F1 by A1 into A2, which is equal to A2 by A1 into F1. By substituting the values of A1, A2 and F1, we get F2 is equal to 90 Newton. And we have to find the distance through which the larger piston move out. Given that L1 is equal to 6 cm, converting into meter, it is equal to 6 into 10 the power of minus 2 meter. As water is considered to be perfectly incompressible volume covered by the moment of smaller piston inwards is equal to volume moved outward due to the larger piston. Then V1 is equal to V2. As V1 is equal to L1A1 and V2 is equal to L2A2. So L1A1 is equal to L2A2. Now L2 is equal to A1 by A2 into L1. By substituting the values of A1, A2 and L1, we get L2 is equal to 0.67 into 10 the power of minus 2 meter. Converting into centimeter, it is equal to 0.67 centimeter. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay. Thank you. Have a nice day.